single replacement and double replacement reactions. You guys have probably done these before, so shouldn't be anything too new. Obviously, it's a reaction between a single replacement, a reaction between an element and an ionic compound. And of course, we're going to do the old switcheroo there kind of thing. The metals will switch places kind of thing, or possibly the non-metals will switch places as well. And you'll see an example of that as well. Remember that, of course, when we form the ionic compound, if there's no specific charge that we start with, it always forms the most common charge at the end. So you have to keep in mind it's always most common stuff, unless it tells you otherwise. Okay. So let's get going right on the examples here. This one here. Okay. You do have to be a little careful how you read these. So this one does say solid silver is produced. Okay. So solid silver is produced between the reaction of copper and a solution of silver nitrate. Now, as far as states go, you know, yesterday we talked a lot about ionic compounds, solids, etc., etc. Well, I'm going to tell you right now, if you go to the lab and you take a chunk of copper and you stick it into silver nitrate, which is a solid as well, ionic compound, if you stick those two together, you know what happens? Nothing. Because they're two solids. They're going to stand there and look at each other. Okay? That's what's going to happen. So we need a way to basically transfer electrons, okay, from one to another, and that's a little bit, you know, it gets a little more complicated next year and stuff like that, but we need a way for that metals to switch places or those electrons to be transferred. So what we do is we put this into water, a solution. Okay? So if you take a chunk of copper and you put it into silver nitrate, you would actually see there's a change there. And actually, that's one of your first labs in Chem 30. Okay? And we'll do a lab similar to something like this anyway, but metals switch places. Okay? Here's my metal here, and here's my metal here, of course. Okay? Metals, of course, are always at the beginning of the ionic compound, and copper, of course, is a metal. They're going to switch places. So silver is going to come out by itself. Copper is going to go in with the nitrate here. So copper and nitrate. And now this is a case where we have to say, hey, what copper is it going to form? Because copper comes in more than one charge. So we have to use the most common, right? So this case, copper 2 is more common. It comes first on the periodic table. So we'll get that there. That, of course, all takes place in a solution. So that is your new, not your new solution, but that's basically still in water, right? You're going to get a solid chunk of silver being produced and some copper nitrate, okay? Balancing-wise, we got copper, copper. We got silver, silver. We got one nitrate here. We got two there. So I need to put a 2 here, 2 nitrates, 2 silvers as well. Okay, and then you're done. All right? Might as well ask you now. Here's the million-dollar question. We'll see who knows their stuff here. Hey, if you know nothing else from Chem 20, please know this. I'm going to ask you, think about this carefully. What is the charge on this copper? Think about it for a second. What is the charge on that copper? And the answer is? I can't hear your whispering. It is? Nope. Nope. I'll take another one. Zero is the correct answer, yes. Right? How do you get charges on stuff? Well, you have to lose electrons. If the electrons are going to be lost, where are they going to? That's the question, right? Copper by itself, right? Copper by itself can't lose electrons because it has nothing to lose them to. What's the charge on this silver right here? And the answer is no. No. Charge on the silver. 1 plus. Silver's a 1 plus. It's part of an ionic compound, right? So 1 plus. Nitrate, of course, is a 1 minus, yes? Nitrate. What's the charge on this silver here? Steven? Yes. 0. What's the charge on the copper? Woo! Huh? What? 2 plus. Sure. And a 1 minus, yes? Okay. So please know, right? That's, that's some stuff that we need you to know, right? When elements are by themselves, it's fine. They don't have a charge, but you have to get charges. They have to, listen, to get a charge, we call it an ion. And an ion is part of an ionic compound. See, ionic compound. Okay? That's where ions come from. It has to be part of a compound in order to have a charge on it. Okay? All right, a little bit of review for you there. Okay, aluminum is placed into, so a piece of aluminum is placed into a solution of tin 2 acetate. Swap and drop, tin 2 plus, acetate's a 1 minus. Solution, okay? Even if it doesn't say solution, like I just finished telling you guys, even if it doesn't say solution, guys, if you took a chunk of aluminum, stick it into a beaker, okay, full of aluminum or tin 2 acetate, you know what happens? Probably nothing, because there's no way for those two things to react together. There's no medium, if you want, okay? So they have to be, one has to be in a solution, usually, okay? Now, would something happen over time? Possibly, because there's moisture in the air, there's other things that are going on there. So possibly, but it would take an incredibly long time, okay? You're going to have single replacement, so metal switch places. You're going to get tin by itself and aluminum acetate. And once again, okay, we're going to get one of these to be aqueous here. This is still going to be a solution, right? You're going to get a solid chunk of silver, or sorry, tin and aluminum acetate, all right? So people always ask, can you get, so I can take aluminum and I can make tin from it? That's amazing. I'd probably then take some aluminum and make some gold, because that's probably worth something. Huh? That'd be awesome. We have to remember, guys, the tin here is just in a slightly different charge, right? Different form. It's got an ion associated. It's got lost 2 electrons, right? We're changing that from 2 electrons that's being lost. We're giving those electrons back to make the solid form again, okay? Just regular tin. That's what's happening there, okay? Balancing. Well, aluminum's good, tin's good. Acetate is 2, acetate is 3. So to fix that, I do this. 6 and 6 acetates on both sides, and then I go back and balance the rest here. So 2 and a 3 there. Okay? All right, good. Okay. We're going to skip one of these here, but we're going to go to fluorine gas here. This one's a little bit different. Please know that fluorine gas reacts with nickel 3 bromide. Okay? Now what you'll notice different about this is the first thing that I have there, that fluorine, is not a metal. It's a non-metal. Okay? So non-metals can switch places as well. It doesn't have to be a metal and a metal. It could be a non-metal and a non-metal. So this is my non-metal here, right? Before it was a metal and it switched with the metal. Now it's a non-metal. It's going to switch with the non-metal here. Okay? So they're going to switch places. Bromine is going to be by itself now. Bromine comes in 2s. And it happens to be a liquid, by the way. You can look over there and it's in blue. Okay? So the bromine is going to come out, and the fluorine is going to get, well, fluorine becomes the fluoride, basically, with the nickel. So then we're going to get nickel fluoride. Nickel 3 fluoride, actually. Like so. Okay? And then once again, we're going to have to balance it based on that now. All right. So balancing wise, let's see here. Let's do a little Christmas action here. F2, F3, how am I going to get that? That's going to be a 3 there and probably a 2 there. Okay? So 6 fluorines, 6 fluorines. I have 2 nickels on that side. I'm going to put 2 nickels on this side and 6 bromines and 6 bromines. And there you go. You're done. Okay? Little Christmas for you. Red, green. Duct tape forever. All right. Good? Yep. It's on one of the molecular elements. I have no brighter, clever friends. Yep. All right. Let's see here. Next. We're going to look at double replacement reactions. Double replacement reactions, usually, not always, so you're going to have to check this out, and I'll show you how to do that, usually form precipitates, solids, okay? Depends on what you're reacting together and the type of reaction, but in this case, double replacement, usually you get a precipitate. So, once again, mixing 2 ionic compounds, aqueous solutions of calcium chloride and sodium carbonate, 1 plus 2 minus, okay, react together. Calcium chloride, sodium carbonate. Okay. What do you get? Well, remember, it's not actually just straightforward. We did actually this in Unit 3, all the different ions that are produced from this, right? We get calcium ions and chloride ions floating around. We get sodium ions and carbonate ions floating around, and opposites attract. And it turns out that when we combine this all together, the metals switch places. That's what we write for convenience sake. So we get sodium chloride, 1 plus 1 minus, and calcium carbonate, 2 plus 2 minus. Okay, swap, drop, and reduce, of course. Now, the states, as far as these go, you have to look them up. So periodic tables out, flip them over to the back side. Sodium chloride, you're going to look up sodium chloride. Find chloride across the top, Cl minus. Find sodium across or underneath it. Very soluble or slightly soluble? Very or slightly? Very. So that is aqueous. We call that. Means it breaks up very easily, right? Okay. Look up calcium carbonate. Find carbonate across the top. Find calcium 2 plus. Where is it? Very soluble or slightly soluble? Slightly, right? Means it's bottom row. Most of this is going to stay together. Therefore, solid precipitate. Okay? This is hugely important. Huge. Because eventually, we are going to ask you to determine the mass of the precipitate you would expect to find. If you get those wrong, there's no way you'll get the right answer. Okay? Just by doing the wrong states there. So you might have everything balanced, everything else might be perfectly fine, but if you get the states wrong, aqueous or solid, and you switch them around, you're going to take the wrong molar mass, and that's going to give you the wrong answer. Okay? So you have to know aqueous solid. What have we got here? 1 calcium, 1 calcium. 2 chlorines, 2 chlorines. 2 sodiums, 2 sodiums. 1 carbonate, 1 carbonate, we're done. Okay? And that should be the balancing for that one there. Alrighty. Barium acetate. Is that good, the top one? Yeah. Barium acetate. 2 plus 1 minus. Solution. reacts with ammonium phosphate. Ammonium is NH4 positive, phosphate PO4 3 minus. Looks like that. Ammonium phosphate. Ammonium's a 1 plus, phosphate's a 3 minus. Gives you, okay, two solutions here. Switcheroo, right? So barium is the metal, NH4 plus, right? The two positive ions need to switch places. Barium's a 2 plus, ammonium's a 1 plus. Those are the ones that need to switch. So you're going to get ammonium acetate and barium phosphate. Like so. Barium, of course, is a 2 plus, phosphate's a 3 minus, swap and drop. Okay? Before we go further, we should probably figure out if one of these is going to be a precipitate. They don't have to be, okay? Usually they are, but they don't have to be. So, find ammonium acetate across the top, find acetate, CH3COOO, and find the ammonium ion. Where does that go? So very soluble or slightly soluble? Very, right? So that'll be an aqueous there. What about phosphate across the top and barium? Slightly soluble, right? So that's your solid. Phosphate across the top, barium's in the bottom. Okay. Balancing, once again, okay, so, well, we have a barium here, we have 3 here, okay? So probably want to start there, I guess. Might as well, I guess. Got to start somewhere. That's why pencils have erasers too, by the way. In case you have to go back and switch it later, you can. I got 3 and 2 is 6 acetates there. 6 CH3COOs. Balance it based on ions. 6 acetates. So I'm going to put a 6 out in front. 6 acetates. CH3COOs. Right? I have 3 NH4s here. I have 6 NH4s, the ammonium ion. So I need to put a 2 in front of here. Okay? And then I have, finally, 2 phosphates, 2 PO4s. And look, 2 PO4s, we're good. Okay? And that should be the balancing there, 3, 2, 6, 1. Okay? Good? Okay? Now, there is neutralization reactions, which are technically a special type. You don't have to know this as separate or anything like that. But just know when you take an acid and a base, you get a neutralization reaction. We talked about that in Unit 3 a little bit. You get a salt, ionic compound, and water usually. Okay? So let's take a look at this one here. Once again, as always, you need to know acids' names, right? Phosphoric acid. What does that look like? If you get that wrong, if you don't get the right formula for phosphoric acid, it's probably going to be pretty much impossible to get this question right. So phosphoric acid means it's hydrogen phosphate. 1 plus 3 minus, right? That's how you write acids using ionic formulas, right? Talked about that last unit. Solution and barium hydroxide. Okay. What do you get as a result from mixing these two? Well, metals switch places. H plus is the metal here. Barium is the metal there. So we're going to switch them. We're going to get some barium with phosphate. 3, 2, and what else do you get? Well, once again, acid plus base equals salt, aka ionic compound, and water. Look, H, right, and OH go together to give you water, right? I would suggest writing it like that. It's going to make it way easier to balance. Now, if you want to write water, I'm not going to stop you. That's great, okay? But I'm going to tell you it makes it way easier to balance if you do it this way, okay? So, states, once again, as always, we're going to look these up. Water, by the way, you don't have to look up. That's a liquid. That's a solid. We just did that one on the last question. Barium phosphate. Phosphate across the top, barium's in the bottom. Okay? Solid. So, where are we going to start here? Well, let's see. 3 hydrogens, 3 H pluses right here. So I probably should put a 3 right here. If I do that, I'll tell you here, look, phosphate, there's only 1 here, but there's already 2 here. Okay? So if I did that first, I'd have to go back and fix that. Not a big deal, but basically there is 2 phosphates there. I probably want to start with a 2 out of here to start with, which makes 6 H pluses here, 6. So I'm going to put a 6 for that H there. Okay? I got 1 barium, I have 1 barium here, and I got 3 there, so let me put a 3 there. And 6 hydroxides, and look, 6 hydroxides, right? So it's all good, right? Now, if you want to rewrite it as H2O, that's fine. 6 waters, same thing, okay? 6 HOHs, whatever, doesn't matter, okay? All right, good? Yes? I think we'll just stop there. That's probably enough for you guys. Examples, yeah? Do you want to do the last one? Yeah? Okay. Hey, why don't you guys do this? You guys do this. All right, so aqueous hydrogen dichromate looks like that. Hydrogen's a 1+, dichromate's a 2-. Acid, right? That's how we form those formulas, I guess. Swap and drop, so we get H2Cr2O7. Lithium hydroxide, switcheroo, right? So hydrogen and lithium are going to switch places. We're going to get some lithium dichromate and some HOH, okay? Now, I don't know if I need to do this, but if you mess up the formulas, okay, so which I have done here on purpose, if you mess up the formula, okay, what happens is you'll never be able to balance it. Because when you think you're done, it kind of starts all over again. So if you're not careful here, and if you left like this, basically I've messed this one up on purpose, by the way, okay? But look what happens if you mess it up on purpose. I won't be as silly as I usually am here, but if you mess up the ionic formula of any of these, right, what happens is you're just going to keep going around and around, and you're going to come to me, if you're doing homework, or if you're on a quiz, you're going to spend 10 minutes going around and around, and it's never going to balance. And it won't, because you've messed it up, okay? And then I always get people, this question's impossible, I can't do it. No, you messed up a little bit something, and you think it's impossible, but when you fix it, it's possible, okay? So, I'll show you what happens if you do this. Remember, this H is right here, right? And this OH here, of course, is right there, okay? So just kind of keep that in mind as we go. Here we go, watch. 2 hydrogens, don't do this because this is wrong, like I said. I'll put a 2 here. I got 1 dichromate, I got 1 dichromate. I got 1 lithium, I got 1 lithium. I got 1 hydroxide. Oh, but I got 2 hydroxides there. So let me put a 2 here. But now I have 2 lithium, so I need to put a 2 there. I got 2 dichromates, so I need to come back here and put a 2 there. Oh, that's fine, but now I got 4 hydrogens. So let me go back over to here and put 4 hydrogens. Now I got 4 hydroxides, so now I got to come back to here and put 4 here. Okay, 4 lithiums, 4 lithiums. Yeah. This works a lot better on the whiteboard, by the way. 4 lithiums. Okay. Oh, 4 dichromates. Oh, I better come over here. 4 dichromates, right? Oh, 8 hydrogens. Oh, geez. I feel like in that never-ending loop of computers, you know? Anyway, so that, you guys don't understand that, I guess, so that's fine. So, like I said, if you mess up any of these formulas, that's what's gonna, you might run into that problem, or it just might not balance, okay? This is good. This is good. Lithium dichromate. Lithium's a 1+. This is a 2-. So just by simply forgetting that 2 there, okay, is the world of difference, right? It's where you get that never-ending loop of computers, or you balance it within like one step, basically. So if you start again here, I got two hydrogens. I got one dichromate, I got one dichromate. I got two lithiums there, put a 2 there, two hydroxides, you're done. Okay? So like I said, it's really important not only to balance, of course, I got to do the states here. Not only important to balance properly, but it's also important to take your time and make sure you get the right formulas for these. Okay? Even if you're off, like for example, acids, like phosphoric acid. What's the difference between phosphoric acid and phosphorus acid? One oxygen. Is that going to make a difference? Oh, you bet it is. Sure it is. It's going to mess everything up for you. Okay? So you can't afford to do that. States, and I'll just give you a note here about this, because I know one of these you're not going to find. That's why I actually don't mind doing this. Those are aqueous. This is, of course, your liquid here. Lithium dichromate, that's on the old periodic table from a while ago. You're not going to find lithium dichromate on your periodic table. So what state is it in? Don't know, right? Perhaps. I will tell you that probably lithium very soluble most of the time. Group 1 elements tend to be very, very soluble. So in this case here, I probably would assume, without looking it up, of course, that this is probably going to be aqueous here. I mean, it's going to be hard for you guys to tell, and I won't ask you that, of course, on your quiz or test or anything like that. You'll find them on the periodic table. They'll be there, okay? But I'm just telling you right now that group 1 is usually very soluble ions. So I would probably think that's probably going to be aqueous, but I probably should look it up just to double check, okay? And I'd have to look up in the old book there to find that one. I'm pretty sure it's aqueous, okay? If you left it blank, that's okay. All right? Good? Any questions? All right. So for homework today, you guys have the rest of, I think you only got 1 or 2 questions to finish on that sheet I gave you yesterday. Number 1 and 2 and 7. 1, 2, and 7, I think. 1, 2, 3, and 7. So 4 questions. I'm going to give you the answers in about 10 minutes. That gives you 2.5 minutes a question, which is kind of what I expect to be able to do. So in 10 minutes, I'll give you the answers for those. We'll double check them. I have another worksheet here for you as well. And you are going to do the front side for tomorrow. Okay? Front side for tomorrow. And we'll go over that quickly tomorrow. Hopefully we'll get to your test tomorrow as well.